Good day, everyone. This is the report of Group 9 in Educ 101, Advanced Principle of Research under Dr. Tarhata S. Kimalon.
Good day, everyone. I am Elaine G. Papelera, together with my partner, Janeline A. Abuela. We are assigned to discuss to you the definition and purposes of sampling. First, the definition and brief history of sampling. Based on Paris 2013, sampling is a word that refers to the method or process of selecting respondents or people to answer questions, meant to yield data for a research study. Sampling, on the other hand, based on Baraciro 2016, means choosing a large population, the respondents or subjects, to answer the research questions. The entire population is involved, but for the research study, we choose only a part of the whole. How do sampling started? The beginning of sampling could be traced back to the early political activities of the Americans in 1920, when Literary Digest did the pioneering survey about the American citizens' favorite among the 1920 presidential candidates, based on Bobby 2014. Now, let's go to the purposes of sampling. First purpose is the economical. In most cases, it is not possible and economical for the researchers to study an entire population. With the help of sampling, the researcher can save lots of time, money, and resources to study a phenomenon. Number 2 purpose is improved quality of data. It is proven fact that when a person handles less amount the work of fewer number of people, then it is easier to ensure the quality of the outcome. Third purpose is quick study result. Studying an entire population itself will take a lot of time, and generating research results of a large mass will be almost impossible, as most research studies have time limits. And last purpose, but not the least, precision and accuracy of data. Conducting a study on an entire population provides researchers with voluminous data, and maintaining precision of that data becomes cumbersome task. Based on Albert St. Georgi, research is seeing what everybody else has seen and thinking what nobody else has thought. These are the references of our report from the book and from the internet. Thank you for watching and listening to our report.
Good day, everyone. This is the report of Edward B. Sanchez and Edilyn C. Oliverio in Educ 101, Advanced Principles of Research, Sampling Key Concepts and Terminology.
Sampling, simply defined as the process by which members of a population are selected for a sample. The sample is the representative of the population. The word population is a technical term in research, which means a big group of people from where you choose the sample. We have the two types of population. We have the target population, which means the entire group of objects, all with one characteristic of interest in common and about which we want to make decisions. Another is research population. This is the portion of the target population available for sampling. This is according to the University of Idaho.
Sampling frame, on the other hand, is the list of the member of the population to which you want to generalize or apply your findings about the sample. Sampling unit is the term referring to every individual in the population. Statistic, to describe any kind of numerical information drawn from a sample. Sample statistics, parameter, any characteristic of a population that is true and known on the basis of a census. Example, percentage of males or females, percentage of college students in a population.
Estimate, any characteristic of a sample that is estimated on the basis of a samples. Example, percentage of males or females, percentage of college students in a sample. Samples have sampling error, an estimate of precision. Estimates how close sample estimates are to a true population value for a characteristic. This is, of course, as a result of selecting a sample rather than surveying an entire population. Standard error, a measure of sample size. Standard error is an inverse function of sample size. Sampling variability. Different samples are likely to produce different statistics for the same population, even when the samples are chosen in exactly the same way. Sample bias, the result of choosing a bad sample, and is much more serious problem than the chance error.
Thank you for watching.
Inside your eyes, you make me feel like I'm awake.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Good day to all of us, especially to our instructor, Dr. Tarhata Isgiamalun, Ma'am. I am Hasmin B. Gandalibo from SGA Carmen Cluster 9. From previous reporters from Group 9, we already know the definition of sampling, why we need sampling, purpose of sampling, sampling concept and terminology. What I will report now is the principle of sampling number 1 and 2. Principle of statistical regularity. Number 2, principle of inertia of large numbers. The first principle is the principle of statistical regularity. This law is based upon mathematical theory of probability. According to this principle, when a large number of items is selected at random from a universe, then it is likely to possess the same characteristics as that of entire population. This principle asserts that the sample selection is random. Example, every item has an equal and likely chance of being selected. It is believed that samples selected randomly and not deliberately act as a true representative of the population. Thus, this principle is characterized by the sample size and the random selection of a representative sample. Number 2 principle. Principle of inertia of large numbers. It is based upon the concept that the larger the size of the sample, the more accurate the conclusion is likely to be. This principle is based on the notion that large numbers are more stable in their characteristics than the small numbers, and the variation in the aggregate of large numbers is significant. It does not mean that there is no variation in the large numbers. There is, but is less than in the smaller numbers. Thus, both the principles talk about the sample size. The larger it is, the larger is the accuracy of the result obtained. Shukran.
Good day. This is the continuation of the report of principles of sampling by Ma'am Jasmine Gandalebo. So, principles of sampling. There are two important principles of sampling on which sampling theory depends on. So the first is the principle of statistical regularity, and second is the principle of inertia of large number. So that was reported by Miss Ma'am Jasmine Gandalebo. So let's recap. So law of statistical regularity or principle: when a large number of items is selected at random from the universe, it is likely to possess the same characteristics of the entire population. So second is the group of objects chosen at random from a larger group tends to possess the characteristics of that larger group. And the principle or the law of inertia of large number. So the larger the size of the sample, the more accurate the conclusion is likely to be. So other things being equal, as the sample size increases, the results tend to be more reliable and accurate. So in dealing with the large number, the variation in the compound's parts tend to balance each other's consequently. So now let's proceed to my report. It's the principle of validity. So ito yung dagdag sa dalawang yun. So if the valid tests are derived, then the sampling design is termed as valid. So the samples obtained by the technique of probability sampling satisfies this principle. So that states the principle of validity. So next is the principle of optimization. So this principle states that with the help of a sample, one must be able to get optimum results with maximum efficiency and minimum cost. So this principle stresses upon obtaining optimum results in terms of efficiency and cost of the design, which the resources at our disposal. So this was research by the management article stocks and investment. So ito yung nahanap namin na meanings ng sampling theory or the principles of sample. Pero there was this that I've researched na meron pang dagdag na dagdag ko lang na research according to readinggrace.com. So there are 4 principles daw of sampling. So it's another principle of sampling. So the principle number 1 states that there will be a difference between the population mean and the parameters and sample statistics. So the reason for this is that the sample is only part of the population but not the whole population itself. So there are several other ways that can be used to get the most representable sample. So different samples drawn from the same population may vary in their sample statistics. So the selection of units to random sampling can help minimize these differences. So the difference that exists between population and sample characteristics is known as the sampling error. So the sampling error can be minimized but it cannot be avoided completely. So next is the principle number 2. So the greater the sample size, the more accurate and generalizable the sample will be of the population mean. So the difference between population mean and sample statistics can be reduced greatly if the sample size is taken large. So taking large sample means greater effort and time to process the data, but the sampling error is reduced. So hence sampling error can be reduced if the sample is large. So pag mas malaki yung sample and sampling error is lessened. So let's proceed to principle number 3. So principle number 3 states that the greater is the difference in the population characteristics, greater will be the difference between population mean and sample statistics. So when the population is varied and widespread, the sample taken also contains greater variability and the results obtained may not be representable and generalizable of the population mean. So the sampling so so the sampling error can result, but it can be reduced by making a cluster or a strata of the population. So strata. By making a cluster or strata, ganyan. So from each strata, sample can be taken, the variability and in the population characteristics can be reduced in this way. So let's proceed to principle number 4. Principle number 4 states that it's about the non-sampling errors or the bias. So, or the biases. So this is all principle number 4 is all about the researcher. So it is also named as the researcher bias. So in sampling from any population, any other error that occurs that has been invested because of the researcher is known as the researcher bias. So faulty estimates and poor use of techniques can also result in errors. And these errors are also known as non-sampling error. So non-sampling error, before selecting sample from the target population, sampling principles should be understood to make the process of sampling valid and reliable. So this was according to readinggrace.com. So these are the principles of sampling. So these are our references in making our report.
Good day, everyone. I am Esnaira Tisa Lilama. Together with my partner, Ma'am Eden Joyce Gonzalez, we are here to present to you our assigned topic about the disadvantage of sampling. Disadvantage of sampling. The reliability of the sample depends upon the appropriateness of the sampling method used. The purpose of sampling theory is to make sampling more efficient, but the real difficulties lie in selections, estimation, and administration of samples. Number 1. Chances of bias. The serious limitation of the sampling method is that it involves bias selection and thereby lead us to draw erroneous conclusions. Bias arises when the method of selection of sample employed is faulty. This also results from a systematic error and occurs when there is a systematic difference between study measurements and the true population values, and as well as on investigators' prior knowledge of the hypothesis. Therefore, it could result to a poor study design and cannot be corrected at the analysis stage. Next, difficulties in selecting a truly representative sample. Difficulties in selecting a truly representative sample produces reliable and accurate results only when they are representative of the whole group. It is also difficult when the phenomena under study are of complex nature. Selecting good sample is difficult. Selection error also causes distortion in the result of a sample, and a common example is a survey that only relies on a small portion of people who immediately respond. Then, inadequate knowledge in the subject. Sampling involves statistical analysis and calculation of probable error. When the researcher lacks a specialized knowledge in sampling, he may commit serious mistakes. Consequently, the result of the study will be misleading. Without having a deep understanding, or if you'll not mull over with a topic about the research, you will not be able to drive into higher, critical, integrative, and creative thinking strategies in finalizing your mind. In that way, There is a lot of possibilities on giving or providing an incorrect information. According to Bobby year 2013, it should always be better if the topic is researchable and supported by evidence that is observable, factual, and logical. Next, changeability of units. When the units of the population are not inhomogeneous, the sampling technique will be unscientific. In sampling, though the numbers of cases is small, it is not always easy to stick to the selected cases. The units of sample may be widely dispersed. Changeability of units also pertains to alteration and alternatives performed by the researcher when sample and subject are unavailable or they cannot be reached due to some reason. In this case, the researcher has to change or replace some cases. Moreover, change alteration of the sample would lead to a bias, unscientific, and incredible results. And lastly, impossibility of sampling. Deriving a representative sample is difficult when the universe is too small or too heterogeneous. In this case, census study is the only alternative. Moreover, in studies requiring a very high standard of accuracy, the sampling method may be unsuitable. There will be chances of errors even if samples are drawn most carefully.
Good day, everyone. My task is to report the general types of sampling in Educ 101 Advanced Principles of Research. When the population size is large, sampling is an important tool in research. Based on this, it is divided into two types, the probability and the non-probability. These two types of sampling are further divided into the following subtypes. The first type is the probability sampling. In this type of sampling, there is a known probability of each member of the population of being selected in the sample. When the population is highly homogeneous, there are high chances of each member of being selected in the sample. For example, in a bag full of rice, if we want to pick some rice, there are high chances of each rice grain of being selected in a sample. Hence, the sample collected will be a representative of the whole rice bag. Probability sampling is classified into four types: simple random, stratified random, systematic, cluster, and multi-stage. What is simple random sampling? In this type of sampling, the members of the sample are selected randomly and purely by chance. Hence, the quality of the sample is not affected as every member has an equal chance of being selected in the sample. Stratified random sampling. In this type, the population is first divided into subgroups called strata on the basis of similarities, and then from each group or strata, the members are selected randomly. Systematic sampling is an advanced form of simple random sampling in which we need complete data about the population. Cluster sampling. In cluster sampling, various segments of a population are treated as cluster and members from each cluster are selected randomly. Cluster sampling and stratified sampling are different from each other. In stratified sampling, the researcher is dividing the population into subgroups on the basis of age, sex, profession, etc. But in cluster sampling, we are selecting randomly from already existing or naturally occurring groups, cluster, for example, towns within a district and families within a society. Multi-stage sampling, as the name suggests, it contains many that have known probability of being selected in the sample. For example, to study the impact of child labor on children, the researcher will search and interview only the children who are subjected to child labor. Different types of non-probability sampling: purposive, convenience, snowball, quota, and consecutive. Purposive sampling. In this type of sampling, according to the purpose of the study, the members, for example, are selected. It is also called deliberate and judgmental sampling. For example, to study the impact of yoga on DCM patients, only the DCM patients can be the best respondents for this study. Every member of heart disease is not the best respondent for this study. Hence, the researcher deliberately selects only the DCM patients as respondents for this study. Convenience sampling, selecting the members of a sample on the basis of their convenient accessibility, is called convenience sampling. In this, only those members are selected who are easily accessible to the researcher. Snowball sampling, also known as chain sampling or sequential sampling. It is used where one respondent identifies other respondents from his or her friends or relatives are known to. This kind of sampling is adopted in institutions where it is difficult to identify the members in a sample. Quota sampling. In this type of sampling, members are selected on the basis of some specific characteristics chosen by the researcher. These specific characteristics serve as a quota for selection of the members of the sample. In this type of sampling, we gather representative data from a group. It is similar to stratified random sampling, which is a type of probability sampling. The only difference between both is in stratified random sampling, the elements of sample are chosen randomly, but in quota sampling, it is not so. Consecutive sampling. In this type of non-probability sampling, the researcher will select the samples according to his or her ease convenience. This is also similar to convenience sampling with little change. In this, the researcher first picks up a group of people for research, does it for some time period, collects samples, gives results, and once the researcher completes, he or she will move on the next group of people. Hence, in this way, a researcher will fine-tune his or her research work with the help of this sampling, and he or she gets a chance to work with multiple sampling.
Now let's discuss the types of non-probability sampling. First, let us define what is non-probability sampling. A non-probability sampling is defined as a sampling technique in which the researcher selects sample based on the subjective judgment of the researcher rather than the random selection. These sampling methods depends heavily on the expertise of the researchers. Let's proceed to the types of non-probability sampling. The first type of non-probability sampling is what we call the convenience sampling, also known as grab sampling, accidental sampling, and opportunity sampling. Convenience sampling is a type of non-probability sampling that involves the sample being drawn from the part of the population that is close to hand. Convenience sampling is a type of non-probability sampling method where the sample is taken from the group of people that are easy to contact or easy to reach. Just like, for example, standing at a mall or a grocery store and asking people to answer questions would be an example of what we call the convenience sampling. The second type of non-probability sampling is Consecutive sampling. Consecutive sampling is the process of conducting research including all the people who meet the inclusion criteria and are conveniently available as a part of the sample. In consecutive sampling, the researchers pick a single person or a group of sample, then they will conduct a research over a period. Then after, they will analyze the results and then move on to the other subject or group of people if needed. In this type of sampling, each of the prospective respondent is evaluated to check if they meet the listed requirement and how easily accessible they are for the study. Once they meet the checklist list, they are included in the sample population to carry out the research. Consecutive sampling gives the researcher a chance to work with many topics and fine-tune to his or her research by collecting results that have a vital insights. The third type of non-probability sampling is judgmental or purposive sampling. Judgmental or purposive sampling is a non-probability sampling technique in which the sample numbers are chosen only on the basis of the researcher's knowledge and judgment. Judgmental or purposive sampling, the researchers choose only those people who they think fit to participate in the research study that they will be conducting. Judgmental or purposive sampling is used primarily when there is limited number of people that have expertise in the area of being researched, or when the interest of the research is on a specific field or a small group.
The fourth type of non-probability sampling is called quota sampling. Quota sampling is defined as non-probability sampling method in which researchers create a sampling involving individuals to represent a population. This means that elements from the population are chosen on a non-random basis and all members of the population do not have an equal chance of being selected to be a part of the same group. Researchers choose these individuals according to specific traits or qualities. They decide and create quotas so that the market research samples can be useful in collecting data. These samples can be generalized to the entire population. The final subset will be decided only according to the interviewers or researchers' knowledge of the population. The fifth and last type of non-probability sampling is called snowball sampling. Snowball sampling or chain referral sampling is defined as a non-probability sampling technique in which the samples have traits that are rare to find. This is a sampling technique in which existing subjects provide referrals to recruit samples required for a research study. This sampling method is often used when researchers wish to study a population where the subjects are particularly hard to identify or reach. Individuals with rare diseases. If researchers are conducting a study of individuals with rare diseases, it may be difficult to find these individuals. However, if they can find just a few initial individuals to be in the study, then they can ask them to recruit further individuals they may know through a private support group or through some other means.
Here are the guidelines for determining adequate sampling. First, when the universe or population is more or less homogeneous and only the typical, normal, or average is desired to be known, a smaller sample is enough. However, if differences are desired to be known, a larger sample is needed. So homogeneous, meaning There are similar in characteristics. That is why smaller sample is sufficient. Like for example, size. If differences are desired to be known, it is needed larger sample. Second, when the population is more or less heterogeneous and only the typical, normal, or average is desired to be known, a larger sample is needed. However, if only their differences are desired to be known, a similar sample is sufficient. So the first and the second one is somewhat opposite. The third one, the size of sample varies inversely as with the size of the population, and a smaller proportion may do for bigger population, meaning a larger proportion is required of a smaller population, and a smaller proportion may do for a bigger population. Like for example, if you have a population of 5,000, a sample of 10% may do. But for a population of 500, a proportion of 30% may be required. Next, for a greater accuracy and reliability of results, a greater sample is desirable. And of course, the greater your sample is, the reliable the results of your study. The fifth one, the biological and chemical experiments such as testing the effects of drugs and the other substances, the use of few persons is more desirable to determine the reactions of humans to such drugs and other substances being tested. And the last one, when the subjects are likely to be destroyed during the experiment, it is more feasible to use non-humans as replacements, such as animals, especially rats. That's all for the guidelines of determining adequate sampling.
Good day. Our topic is about steps in computing the size of the sample. Scientific studies often rely on surveys distributed among a sample of some total population. Your sample will need to include a certain number of people. However, if you want it to accurately reflect the conditions of the overall population it's meant to represent. To calculate your necessary sample size, you'll need to determine several set values and plug them into an appropriate formula. Step 1. Determine the size of the target population. Population size refers to the total number of people within your demographic. For larger studies, you can use an approximated value instead of the precise number. Precision has a greater statistical impact when you work with a smaller group. For instance, if you wish to perform a survey among members of local organization or employees of a small business, the population size should be accurate within a dozen or so people. Step 2. Determine your margin of error. The margin of error is a percentage that indicates how close your sample results will be to the true value of the overall population discussed in your study. Margin of error, also referred to as the confidence interval, refers to the amount of error you wish to allow in your result. Smaller margin of errors will result in more accurate answers, but choosing a smaller margin of errors will also require a larger sample. When the results of a survey are presented, the margin of error usually appears as a plus or minus percentage. For example, 35% of people agree with option A, with a margin of error of plus minus 5%. Step 3. Use the formula. We have here the Sloven's formula, which is n is equal to capital N over 1 plus n and small letter e. Small letter n refers to the sample size. Capital N refers to the size of the population. Small letter e refers to the margin of error. I am going to show to you the computation using Sloven's formula. Given population is 5,346 and the margin of error is 3%. Let us just follow the formula. Step 4. Compute the sample proportion by dividing the result in number 3 by the population. So this is the sample proportion. Small n, which is the sample size, over capital N, which refers to the size of the population. Let us put the equivalent numbers. Then divide. The answer is 0.17 or 17%. Again, these are the steps in computing the size of the sample. First, determine the size of the target population. Second, determine your margin of error. Third, use the formula. Fourth, compute the sample proportion by dividing the result of the computation by the population.
These are the reporters of Group 9. To end our report, we would like to give thanks to Dr. Tarhata Gimalon for assigning us this topic. Again, good day everyone, and God